First thing I want to do is get the background surfaces of this rectangle. So I'm going to use a surface component and just plug my rectangle outline directly into it. This automatically builds nice little surfaces. And now I want to blow up this surface in order to get the edges and the vertices. And I go to the Surface tab, and I'm going to use this Deconstruct BRep. Now if I hover my mouse over the output, I'll see what is the data tree structure. I have those two numbers in parentheses with a semicolon in between them, and then n equals 4. And this is edges. So if you want to be able to see these trees a little bit better, there's a few ways to do that. The easiest is to use a panel, and if you plug it in, you'll notice up here it lists the tree path, and then on the left it lists the item. So when it says n equals 4, you can then count 1, 2, 3, 4 with the item index listed. And if you scroll down, you'll see that the branch path is increasing each time. Another way to review this is to use something called Param Viewer. If you plug this in, it gives you less information. Doesn't tell you it's a curve, but it does simplify the structure. So it says I have 143 branches. As I said, I have 143 values, so this here says right away 143 branches, that's what they are, and this is the number of items each. You can also, if you right click on this Draw Tree. Now this is maybe not the best structure to show, but this can visualize the tree structure for you. I personally don't find this very useful. If you have more simplified branching structures, you can see how at each level of the tree it'll draw it out like a physical shape. And there's also a command called tree statistics that can give you some more detailed information. So this will output the actual path, every single path that is in that tree. It'll tell you the length of each, all the items in each tree, as well as the total count. So there's a variety of different ways of getting this information. I recommend using Param Viewer or just the panel, or even hovering over the inputs or outputs in order to get information about the tree. So it's very important that we learn how to read and manipulate these data trees, because I guarantee you it's probably 90% of the bugs or errors that you're going to run into in Grasshopper are related to your trees being misaligned. Just like in Volume 1 we looked at how important having your lists aligned was. If you didn't have them set up properly, your whole model would freak out and you'd have all these errors. Well, trees, it's doubly so. It becomes even more critical to have them set up right, which means we need to know how to adjust them. So I'm going to go through some of the most basic tree commands. So let's create a surface. Let's bring out this from F into here. This is a simpler tree. So let's take a look at what this is. Here we have 143 branches, one item each. Now notice if I scroll down, all of them have this 0 in the front, which is extraneous. It doesn't, there's really no need for it to be there. So the first command we can do is called simplify. So go to simplify tree, and if I plug this in, you'll see that it's gotten rid of that. And it will only get rid of these values if every single branch that goes into here has that same value, meaning it's not adding any additional information. So now what we have, we can think of it this way as branch 0 is panel 0, and branch 142 is panel 142, and they each have one item associated with them. So in this way we're able to group everything through our data structure. We're grouping them based on panel. Let's look at another command. Let's look at Flatten. This is the nuclear option of trees. So if you were to plug in any tree into Flatten, no matter what it is, it's going to output a single list. So now it says I have one branch and I have 143 items. I just destroyed the entire tree, chopped it down to its stump, and now everything is in one long list. This is often very useful, but I strongly encourage you against using Flatten because you can lose a lot of information this way and it's hard to go back. So just be careful with it. As you'll find as you use it more and more that there may be better ways than to flatten the list to do something similar. So if you can go and reduce the complexity of a data tree through something like Flatten, you can also go the opposite way, which is called grafting a tree. So if I were to take that flattened list, throw it into Graft, what it's going to do now, let's look at this tree structure. In a way it reversed it. It created a new branch for every single item that I had. And now I have that extraneous 0. If I were to plug that into Simplify, I now have a nice clean tree. So Flatten, Graft, and Simplify are some of the most common basic tree manipulation commands that you can do. In fact, they're so common that you will never use these components again, because in any of our containers, these parameter containers, if you right click, you see those same commands are listed in here. So let's take a look. If this was my raw command, I could have just clicked Simplify right here. I could then choose to maybe flatten the output. Maybe I want to graft it to begin with, and then simplify. So you can run all those commands directly in the start of most of these commands. Nice little feature. Now let's get into a more complicated data tree. Let's look at the edges. So I'm going to collect the curves. Let's turn these off. Okay, and let's bring this down. So the curve has the same branch structure, basically one branch per panel, but now I have 4 items. And this is really going to show why grouping it this way might be helpful. So the first thing I want to do, let's go ahead and simplify the tree. And let's try to visualize this tree. So if we go all the way over to the beginning of our script, I've included a little tiny cluster to make this bit of the exercise easier. For those of you who might not have the sample file for some reason, you can just follow along. It's not really critical to the script, it's just helpful to visualize some things. So what this does is it'll take any data tree and it's going to create a little tag from a point so that we can visualize the branch name out here. So let's do this. If these are, actually, rather than curve, let's use point. This will be a little simpler. So if I use the vectors, or sorry, the vertices, which are all of these points, and if I plug that directly into this cluster, it's now going to give me a tag for every single one of these points. So using the text tag, this says give me a location, which is the points that I have, and then plug in this tag, and what it's doing is it's tagging every point. Let's turn this off. So now every point is given its branch and its item number. So let's take a look at what's going on here. So for branch 0, 0, and in fact if I were to simplify, makes it even cleaner. So branch 0 is panel 0 down here, and I have items 0, 1, 2, and 3. If I were to scroll somewhere in the middle, this here apparently is panel 59. And notice it still has the same item structure, the same corners, 0, 1, 2, and 3. Now this is really powerful because let's consider our logic, what we're trying to do. I want to develop a script that can find this corner and this corner, build a line between them, so I can move forward. That's my first step, is to find these 2 points. Well, because I have all of my vertices organized in this way, using a tree structure, I now want to find items 1 and 3. So let's jump ahead and do that. If these are my points, notice that I have 143 branches, each with 4 items. If I say list item, going to start at item 0, and I want items, I say 1 and 3. There's item 1 and 3. Now let's do the same thing we'd started with. And all of a sudden you'll see that every single panel has this drawn. I'll turn this off so we can see it. And it's all done parametrically. So that's much, much faster than, say, manually building this or trying to code it from a single flat list. What I'm now able to do is leverage a tree structure or a data structure within Grasshopper in order to build nested logics. So if one part of our script was the logic behind how to subdivide this this facade and how to create the offsets, that's all been done, that's all set aside. Now I can say, let's zoom in and consider the logic of one panel. And I don't care if it's this tiny panel or a huge open panel. It's parametric. It can be any size panel. All I care about is that I have a little rectangle that I can subdivide into these 4 points. So that way, all I have to do is develop this logic, and it can be repeated across every single panel by leveraging data trees. And odds are good, if you find yourself copying and pasting code, that could be done through a better use of a data tree structure. So it's going to save you a whole lot of time and allow you to do things that you could never script otherwise.